So what is our aim? So our aim is simply to extract pure aluminium from aluminium ore. So aluminium ore is usually, we call it bauxite, and it's mostly composed of aluminium oxide with some other impurities. But we want just pure aluminium. So what properties can we actually exploit? There are certain properties of aluminium oxide and aluminium ores that we can actually exploit to help us remove the aluminium from the aluminium ore. First one is that aluminium oxide, which is Al2O3, is soluble in sodium hydroxide, while impurities are not. If I took a chunk of bauxite and I put it in sodium hydroxide, I know that the aluminium oxide will dissolve, and then anything that's not dissolved will be impurities, which I can then filter away. I put the aluminium ore in NaOH, and then all of a sudden all of the aluminium oxide dissolves, and whatever's left over I know are impurities, so I can actually remove them. This resulting mixture can then be filtered to remove these impurities, and pure aluminium oxide can be recovered. So after we filter it, we can actually get back to pure aluminium oxide. So we're part of the way there already. Now, aluminium oxide has a high melting point, which is bad. We dissolve the aluminium oxide in a molten solvent called cryolite. Before we use electrolysis or electricity to decompose this aluminium oxide into pure aluminium. So what we do is we dissolve it in this cryolite, and then it becomes molten and liquid, and then we use electricity to separate the aluminium and oxygen, and then we get pure aluminium and some impurities as well. So what do we actually do? If we were a mining company, this is how we would proceed. We'd take the aluminium ore, which is just this rock that we know has aluminium in it. We grind it up into a fine powder, and that helps us to remove some of the impurities. So we first grind it up into a fine powder. Then we dissolve that powder in the sodium hydroxide, as I mentioned. And then this solution, once we've dissolved our powder in it, is filtered, and that removes the impurities. And most of those impurities are iron oxides, so they form insoluble iron hydroxide compounds. Most of these impurities are iron oxides, so we actually just want the aluminium oxide. The solution is acidified, and that precipitates out the aluminium hydroxide that forms. So when we put aluminium in sodium hydroxide, it forms aluminium hydroxide. And then we use acid to remove this, or to get it into solid form again. And then once we have the solid aluminium hydroxide, we filter it, and then we dehydrate it by heating it. We get this to precipitate out, becomes a solid. We filter it out, and once we have it, we heat it, and we get back to aluminium oxide. So this is now pure aluminium oxide. There's nothing else in it. There's no impurities. It's just aluminium and oxygen. Now all we need to do is just get the aluminium out of this compound. So we dissolve this aluminium oxide in molten cryolite, which is sodium aluminium hexafluoride. That's at 1000 degrees Celsius, so it's very high temperature. And at that very high temperature, we use electrolysis using graphite or carbon anodes and an iron tank cathode. So the anode is the positive electrode, and the iron cathode is the negative electrode. So connected to essentially the power source. This one's the positive one, this one's the negative one. So liquid aluminium forms at the cathode in the iron tank, and it sinks to the bottom of this compound, and then you open up a valve, and then the aluminium leaves, and we can run it into molds. Okay. So what are some issues regarding the waste? So at an aluminium plant, exhaust gases are a major problem. So we emit mostly HF, CO2, and SO2. This is a contributor to acid rain, sulfur dioxide. This one here is the global warming gas. For those who think climate change is caused by humankind, this is a major contributor of that. And this one, HF, is a very toxic chemical called hydrogen fluoride. It's used in the solar cell manufacturing process as well. Essentially what it does is it's extremely poisonous. Even if a small amount gets into your body, it can cause death. This is not something that we want floating around in the atmosphere. So because it's so dangerous, we have to ensure that there's none leaving the plant. Absolutely zero. We can actually put this HF back into the aluminium oxide electrolytic cell. When we've got that molten cryolite aluminium solution, essentially, we can pump this back in and it will dissolve back into that molten solution. That's not a problem anymore. So it essentially just keeps recycling itself through the process. So that's not a big issue. Sulfur dioxide can be reduced if we use very high quality graphite. So some graphite has sulfur in it. If we use very good quality graphite, it won't have much sulfur in it, and then we can avoid that issue completely. Carbon dioxide is released by the oxidation of the carbon electrodes. So what happens is the carbon electrodes, the graphite, actually takes up oxygen and becomes carbon dioxide, and it is emitted. So if we use something that's not carbon, maybe that might help, but we haven't found anything that's cheap enough and also as hardy as graphite is. So this one's still an ongoing issue. Now, another huge problem is that aluminium refinement is an immensely energy intensive process. I've heard of aluminium factories which had to build power plants basically right next door because they just consume so much power. So it's an immensely energy intensive process. Some people have given aluminium the nickname solid electricity because it just takes so much electricity to give you pure aluminium that you might as well just call it electricity in solid form. So that concludes today's lesson on aluminium refinement. So we looked at the process, and while there's a lot of chemistry in there that you may not yet understand, as we go on through the chemistry course, you'll fully understand every piece of that without a problem. So we'll move on to the question segment now, and we'll see if you can answer some questions on this particular process.